Okay, so we have two problems that we're going to be working on here where we have two-way tables. These are really useful, but before you can really use them, you need to make sure you do the totals. So that's what I've done here. I've taken this table right here and I've totaled across. So we have Democrats 47 plus 13, which would give us 60. And we have Republicans 36 plus 40, which would give us 40. Then I add how many males were in the study. I have 47 plus 36, which is 83, and 13 plus 4, which is 17. That's really important. You need to get your totals. And you can see, obviously, that we totaled 100. When you have that, if you totaled both of these rows, you'd have 100 people that are in our study. So it says, what is the probability that we get a Democrat? Well, the probability that we would get a Democrat is right here. How many Democrats do we have? Following this all the way over, we have 60 total Democrats out of 100. 60 out of 100 is 60.6 is the probability. What is the probability that we select a female? Well, here are my females. I have 13 and 4. So there are 17 out of 100 in this study, 17 out of 100 that were female. Okay, lots of males in this study, not a lot of females, right? That's what I'm seeing here. In this next one, it says, what is the probability that I get somebody that is a female and a Democrat? Female and a Democrat. So we need to figure out where that is. Here's female, here's Democrat. Female and a Democrat, there are 13 out of the 100. There are 13. So what's the probability? I select one and they end up being a female that's Democrat. Well, there's 13 of those out of the 100 people. And last but not least, what is the probability that they're female or Democrat? Well, that's equal to this, and this is important for you guys to know, and I will put this on the quiz if I ask an OR problem. I will put this here for you so that way you can see it. The probability of being female or Democrat is the probability of being female plus the probability of being Democrat minus the probability of being female and Democrat. Let me explain why. So I'm going to take my 17%. So my 17, the probability, I'm going to say, what's the probability of being female or Democrat? Well, I have 17 females out of the 100. Plus the probability of being Democrat, I have 60 out of the 100. So I'm going to add the 60%. Why am I taking out the 13? Let me explain why. Watch my finger. I do female, 17 out of 100. I do Democrat, 60 out of 100. I've just crossed this twice. I've counted these 13 people in the females, and I've counted them again in the Democrats. I've counted them 2 separate times. We don't want to do that. We only want to count them 1 time. So we have to take them out 1 of the times. So I'm going to take out that 0.13 or the 13 people, and we get 64%. I have a 64% chance of getting a female or a Democrat in this study. Okay, you guys get 1 more of those. This is talking about eating breakfast, not eating breakfast, male, female. So you get another one that looks like that, and you'll have one of these for sure on the quiz with 2 different questions. So make sure we understand how to use this, and it's the same kind of breakdown. They've already given the totals, which is nice, but it's not out of 100, it's out of 595, so I'm going to go over these pretty quickly. The probability of getting a female, if you just randomly draw somebody, is, well, there are 275 out of your 595. The probability that they eat breakfast, that's over here. There are 300 people that eat breakfast out of the 595. The probability that they are female and eat breakfast, that's this 110, female and eat breakfast. Okay, right there. And that middle one, 110 out of the 595. And now they're asking the same question that you had above. What's the probability that we get female or eats breakfast? I already found female, probability of female. That's where you're seeing these percentages. But let me talk about it again in context of here. So watch my arrows. The probability of, that means if I was doing an OR, I would take the probability of being female, 275 out of that 595. Or eats breakfast, I'm going to then add plus 300 out of 595. But the only problem is I counted that 110 here. I counted that 110 here. So I'm going to take out minus that 110 over 595. Those are all the probabilities that are in this part right here. So I'm going to take my 0.46, my female, plus my eating breakfast, plus 0.50, and subtract out the one that we counted twice, that 0.18, the 110 people. And I get 78%. And that is all for my two-way table example.